Okay, so this is the final set of slides. I'm just going to run over a couple of modules and some specific detail on two modules that we've written in near form that we use in our microservice systems. One called Kafkaesque and one called Microbial. So I'll just run over a bit of background. So I'll talk a bit about Kafka and Zookeeper. I'll talk about the Kafkaesque driver, which implements the point A Kafka protocol, and then I'll talk about how we layer microservices on top of that driver. So, and again, you have to forgive me because these are kind of separate presentations. So I would have spoken about what microservices are. I guess the key thing here is that Martin Fowler, who many of you will recognise that name, one of the key luminaries in our industry, is now talking about microservices. So go check out his quotes on it. I like Richard's definition. That can be rewritten in a week or less. I think that's kind of one of the key things. It kind of implies the kind of social aspect to microservices, the kind of change and development teams that it brings. So what's Kafka? Are you guys familiar with kind of queuing messaging technologies? Would you cover that, Eamon, in the course? Or?
Not in our course, but it's probably part of your super systems program.
Yeah. Okay.
Something good.
So it's a partitioned, replicated, distributed commit log service. So producers, a producer process can publish messages into a Kafka topic, and consumers can then subscribe to those topics and process those messages. And they can do that in a couple of ways. It supports both a pub/sub and queue-based semantics. It runs as a cluster, so it's fault tolerant, and each server in the cluster is referred to as a broker. And it actually grew out originally out of a project at LinkedIn. I think the original use case was loading data into a Hadoop cluster, very, very high data volumes. Oops, there we go. I also talk about something called Zookeeper. So Zookeeper was originally a Hadoop sub-project, and what it does is it gives you centralized configuration. So when you have a distributed system, you've got many, many nodes in that system, you need to coordinate them in some way. So Zookeeper is a service that allows you to coordinate that, to have a centralized configuration, and then for those nodes to get updates of that configuration as they occur. It's replicated for high availability and has a pretty simple API. The analogy is a bit like even writing to a file system. So just to give you the kind of structure of what I'm talking about, we're talking about services being written using the Microbial toolkit, which is layered over Kafkaesque, which talks the Kafka North protocol into your Kafka cluster. And then Kafka will write some of its configuration information to Zookeeper. Microbial itself will also store configuration information in Zookeeper. The type of system we're building is similar to the previous slide, is where this main bus, this role here is fulfilled by Kafka. So Kafka is your kind of messaging infrastructure, if you like. And then we're hanging various service pools off of that to perform tasks. And there's some that's going to kick off inbound processing to the system. That could be web, it could be scheduled, it could be anything. Typically there's some kind of data store or data processing going on, and then maybe some results coming out of the system. So there's many entry points into the system, which may be fulfilled by different technology stacks. This could be a PHP lab stack, if you like, or it could be a mean stack here. The kernel of the system is arranged around this Kafka bus.
Peter, the service pools, just practically speaking, say from a node point of view.
Yep.
Would they be, say, a node module with a group of services in that module?
So
or would they be?
These would be individual processes. So each service would be an individual process.
So just one process does one thing.
Correct. But distributed across many instances, right? So you might have within this infrastructure here, you might have say 10. If you're talking about AWS, because I kind of do by default, then you might have 10 instances, and you might have 10, 20, 30 services deployed in each instance. and they're subscribing to messages from this bus here.
Okay. So it's a lot of independent processes.
Correct. Yes. What we do as well is we would deploy those using Docker, so we would actually containerize those processes and push them out in that manner rather than pushing them out as just code. So just to speak a bit about Kafka, we have producers putting messages into a cluster, and consumers pulling them out and doing something with them. It supports both of the kind of common messaging semantics. So queuing is where you typically have a pool of consumers that read from a queue, and each message will go to one consumer only. PubSub is where messages will be broadcast to all consumers. So Kafka supports both of those by using something called consumer groups. So each message that's published into a topic is delivered to one consumer instance with a consumer group. So if I have 10 consumers and they all have a different consumer group name, then that will act as PubSub, then we will see it. Whereas if they have the same consumer group name, it'll act as queuing and only one of them will see it. So you can mix and match those semantics. So here's an example diagram of that. So I have two consumer groups, a couple of servers with different partitions sitting on them, and they'll be distributed based on the consumer group ID, not on the actual consumer ID. So why is Kafka good for microservices? Well, it provides you with that central bus for the system, which you can run locally. I can run a Kafka or a single node Kafka cluster on my Mac here, or we can run a scaled-up cluster in production, and it supports both of those semantics. We like the fact that it's a commit log, so the messages aren't just thrown across the bus and lost. You can actually replay from point in time, so I can actually connect to a Kafka topic and then replay from a given point in time. I can get all that stream of messages, so I can actually post-analyze what's happened on the system. And I think that opens up some interesting possibilities around analysing how your system is working. You can look for standard messaging patterns. So when I get this message in, I normally see two of these resulting from another service and then one of these. If I don't see that, something's gone wrong. So we're kind of very interested in how that plays out. We don't have all of the answers or ideas around that, but it's definitely an interesting area. So Kafka breaks down into topics, and each topic breaks down into a set of partitions. So this is what a topic might look like with three partitions, 0 to 2, right to going in on that topic, and then typically you'll distribute them over partitions to scale. Those partitions that will then be written across several physical machines, and you have what's known as a partition leader. So the partition leader is the kind of the point at which you must read or write to or from, but then that partition is then distributed across into other nodes in the cluster so that you don't lose data if one node goes down and continue to operate. So producers push into those partitions. Typically, you'll round robin across partitions in a topic just to load balance. But you might use some kind of hashing key, and that's up to the producer to set that. Consumers are set in a consumer group, and supporting PubSub or queuing semantics. Kafka provides you the following guarantees. So messages sent by producer will always be appended in the order they're sent. Consumer will always see the messages in the order they're stored in the log. And with a replication factor of n, we can tolerate n-1 server failures. So we do have high availability there. We can cope with server loss. So Kafka implements a binary protocol, and it has the following points. So it has a metadata API. What that does is allows you to get information on topics, partitions, and leaders. So tell me how many partitions I have in a topic, where do those partitions live, and which is the partition leader, which is the node I need to address to talk to this partition. Produce API to allow me to publish information in. Fetch allows me to pull messages from topics. So Kafka is always pull-based. The client is pulling messages from a cluster, and it's using a long poll type semantics to do that. An offset API to allow me to read an offset within a partition based on a timestamp. And this is very interesting. Coming in the next release of Kafka is the offset commit and fetch API. So at the moment you have to actually manage your offsets yourself in the clients, and that's what we're using Zookeeper for. But in the next release there'll be an API to support that. So all of that Zookeeper configuration will be dropping, and we're using a centralized offset management system that Kafka is providing. So let's just speak about that. Just to be really geeky. This is what this is a typical request response. This is a metadata request to Kafka. So if you like this kind of stuff, you can slice and pick from the packet. Essentially, you send it out and you get a correlation ID back, which allows you to map into a callback that you might have stored in the table to process the responses. Okay, so Kafkaesque is one of our modules that we've written that we've used to layer over Kafka. We're tracking 0.9. We implement 0.8 right now. So here's an example use of the module. Requiring Kafkaesque, we need to provide it with one broker. We only need one broker, and it'll go and figure out where the rest are. We provide it with a client ID and a consumer group there. And this is just making a metadata call. So once the library's been torn up, I'll make a call for metadata against this topic, and I dump that information out. So it's pretty simple to use. It's pretty straightforward to use to do a metadata request. Producing is pretty simple as well. You just call produce, and I'm writing two messages here, watching your short geezer. Those two strings are being sent with messages over Kafka. So those will actually go on to a topic called testing 123 in partition 0. Those two strings will be written as independent messages, which can then be called by the consumer, and the consumer looks a little bit like this. So, the producer here is just a two-shot deal. So it's sending two messages and then it's tearing down and exiting. The consumer here is calling poll. So this is going to poll forever essentially. What's happening here is that, again, it's polling testing 123 on partition 0. When it gets a message, it's dumping it to the console and then calling commit. So what commit is doing is saying, I've handled this message, please move forward one, please move the offset forward one. Under the hood, what that does is those offsets are then written into Zookeeper at the moment, because that's where we're doing our offset management. In the future, there will be a message back to Kafka using the offset commit API, and then obviously our handling one as well. This process will continue until you hit Control C, because it's just going to continue polling the messages.
And you can conceivably a producer as well, vice versa.
Absolutely, yep. So let me show you that now. So Microbial is our